Okay, welcome to Data Wrangling with Pandas. My name is Rebecca Bilbro, and I'm going to give you a little bit of background about me and the Data Academy, and then I'm going to jump right in to data wrangling. So the way that this class is sort of laid out is we're going to talk first about what data wrangling is, what sort of tasks are associated with data wrangling, and I will ask you to sort of engage with me and tell me a little bit about how you are currently doing these tasks. And then I would like to tell you a little bit about how I do these kinds of tasks in my work with Pandas and with Python. So a little bit about me. I, like you, am an employee of the U.S. Department of Commerce. I work for the Commerce Data Service. I'm a data scientist, which means somebody who works a lot with a lot of different data sets. In my case, data scientist ends up translating into doing precision policy, usually related to predictive and machine learning tasks. I work a lot with ITA data sets and NOAA data sets and census. In addition to being here at the U.S. Department of Commerce, I am a board member for Data Community DC, which is one of the largest data-related meetups in the country. And some of you may already be members of some of the kind of composite groups like Data Innovation DC, Data Science DC. There actually is, I'm pointing this out because there actually is a meetup group for data wrangling, and they are called Data Wranglers DC. So they are part of Data Community DC. It's, they organize free events. You can Google Data Wranglers DC and look for upcoming events or get signed on so that you get the automated emails when they have an upcoming event. But they have, free speakers. You can go and listen and hear about techniques that people are using in industry. Most of the speakers are people who either work in government or in some government adjacent field, because it's mostly people from DC, Virginia, and Maryland. So I would strongly suggest that if you are interested in kind of engaging beyond this class and hearing some other perspectives of people who do data wrangling as their work. In addition to that, I also teach at the Georgetown School of Continuing Studies in their data science program. I don't usually teach data wrangling for them, but I do teach machine learning. And so you might notice that the way that my perspective of data wrangling is definitely colored by the fact that I think about data wrangling as part of the machine learning pipeline. But I will get to that later, and you're welcome to trouble those notions because I do definitely have my own perspective of what wrangling is for. I also am a faculty member at District Data Labs, which is another data science education platform. I would strongly suggest, if you're interested in learning more about data science and wrangling, to check out the District Data Labs blog. There's a bunch of free, posts that you can access with code and information about how to do, different kinds of data science related tasks. Mostly it's in Python and a little bit of R code. But those are really good posts. And I have a couple posted up there mostly about machine learning, because that's what I do. Also here with me today is Carl. I don't have a picture of him, but for people in the room, you can see him. He's one of the residents That's part of the Commerce Data Service and Data Academy. Your home is Patent and Trademark, USPTO. So he has kind of a full-time job there, but is doing a residency with the Commerce Data Service to explore some of the techniques that we use and figure out how to import those into the regular activities in his work. So he will be sort of serving as my co-teacher or TA. For people in the room, that will mean that when we have kind of the workshop lab time, he'll circulate with me. For the people who are on WebEx, he's the person who is fielding all of the questions. So he'll be able to probably answer most of the questions. If ones come up that sort of are relevant to everybody in the room, he's authorized to interrupt me and raise those questions, and he'll say them, he'll speak them out loud into the microphone so everybody in the room can hear the questions that are coming through the WebEx also. So, a little bit about the Commerce Data Academy. It's been going for a couple of months. Some of you may have taken one or two of the classes that I taught at the beginning. I taught an Intro to Data Science class, and then I taught a class on using Git and GitHub for collaborative software development. But the Commerce Data Academy is it's a data education initiative. It was launched by the Commerce Data Service. The idea is to make more utility than we can give by just developing projects, but also to convey some of this information to the entire Department of Commerce to raise up the data skills of everyone who's interested. So most of the classes are data science and data engineering related, and we do have a couple more that are coming up. There's a machine learning one coming up in maybe a couple weeks. And maybe there's a handful of other ones that are coming up. So if you are interested, you can check out the schedule or send an email to dataacademy@doc.gov. Also, if you want to check out past courses, if there's something that you missed, everything that we've delivered already is posted on our GitHub page, so you can actually access slides and code that have come before in previous classes. So if you missed anything, you can catch up a little bit. So goals for this class. So my goals for this class are these. I want to try to explain what data wrangling or munging is. So these are kind of rough synonyms, wrangling and munging. I want to give you kind of a feel for the tools that are out there for data wrangling, and then I want to specifically dive into what Pandas can do. And then I want to finish up by making sure that I've done a good job of articulating both the benefits of Pandas, like when you would want to use Pandas over a different tool, and also some of the limitations of Pandas, so when you would maybe want to seek out a different tool instead of Pandas. Because one of the things that you learn when you do data analytics and data science is that there's no kind of one purpose tool that does everything. So you kind of have to have a suite of tools at your disposal to do everything that you want to do. So your goals, what I would like you to think of as your goals for this class is, by the end, I want you to be able to explain to somebody what data wrangling means, and also be able to explain why it's so hard and why it takes so long. I think that this is, if that's all you get out of the class today, I think that will be useful. I was just talking to somebody that I work with this morning about how much time data wrangling takes and how hard it is to articulate up the chain of command why you've spent so much time wrangling a data set to make it have utility for analysis. So my hope is that this class will equip you with some vocabulary and some some sort of talking points that you can use to explain why this is so important and why it takes so much time. So if you can do that by the end, that is great. Also, if you can use some of the tools from Pandas to make wrangling a little easier for you, that would be kind of the gold star. And then because I like machine learning and because I'm going to be teaching machine learning coming up in a couple of weeks, I would like you to at least kind of have a feel for how wrangling kind of fits into the machine learning pipeline. So what kind of happens next after wrangling. So you've already seen these prerequisites. You got an email last week, I think, kind of explaining what you would need to do all of the things for this class. So I realized that installation is a little bit tricky when you have a government computer, and so if you are having issues or if there's some blockers there that you want to try to work through together, we can. I've tried to set the class up so that even if you couldn't get most of these things, that you could still follow along and absorb the lessons. So so for that, I've kind of posted like static IPython notebook files on GitHub, so even if you can just access the web and access those notebooks, you'll be able to read the code, even if you aren't able to execute it on your own machine. But basically what you need, if you do want to run the code, is you need a GitHub account, you need Git, the software installed on your machine, you need Python. If you have a Mac, you already have Python. All Macs come with Python installed already. Yay. And you can test that by opening up your terminal and just typing Python, and it opens up an interpreter. But if you are sort of new to these tools, I would strongly encourage you, whether you have a Mac or a PC, I would encourage you to get the Anaconda's distribution of Python because it comes with basically every tool, every package that you'll probably need, unless you do some very sort of like specialized kind of work that requires special packages. But even then, you can always use Conda or pip to access those additional packages. The packages we're going to use today are Jupyter, which is a browser-based Python execution tool, NumPy, Pandas, maybe a little bit of Matplotlib, and SQLite, which is a mini database tool. And then you need to be able to use your terminal or bash or PowerShell if you want to run the code. So I'm not sure if there's any questions at this point. Okay, any questions in the room? Okay. So I'm supposed to give this statement that about open source installations. So in the data service, we all use open source and free software, and that is not because it's open source and free, but usually because for the stuff that we do, those kinds of softwares are the best because those are the things that are in active development. They kind of get at the very cutting edge of the kind of work that we want to do. So, but the idea is to kind of make sure that this doesn't have a huge impact on your IT department. There is guidance about using open source software and GitHub. You can find that policy at this link. So if you need to send it to somebody in your department, you can forward them that. Because each bureau CIO has slightly different rules about installations and IT policy. Okay, so a bit of review. So now I guess we'll find out like who was in my data science class or who remembers back that far. So what is data science? Any ideas? You want to throw out some adjectives or nouns or anything? What do you think? Doing science with data. I like that, actually. That's sort of what I feel like is what I do. So what does that mean, doing science? Okay, so testing hypotheses. But yeah, finding correlations and effects, kind of following some systematic process that's hopefully repeatable, so that other people can check your work and duplicate results theoretically or improve upon them. Generalizable. So how is data science different than like data analysis, or is it different? So somebody in the room suggests that data science is broader. Data analysis is like maybe a subcomponent of data science. I think that seems like a reasonable way to express it. I think that maybe you could also kind of say like it's like a progression, like we've sort of progressed from doing data analysis to doing data science. So some people articulate it as like an evolution. Some people just say it's rebranding, which is fine if that's what you think also. I think to have an operational definition, this is sort of the definition that we use at the Commerce Data Service. This is from our chief data scientist here at the U.S. Department of Commerce, Jeff Chen, who says data science is the practice of transforming raw data into insights, products, and applications to empower data-driven decision-making. And I won't read the rest, but basically it says that it has a tradition and other methods, but it's well suited to the sort of data age because it includes kind of skills and techniques that can scale up to large amounts of data and kind of non-traditional types of data like text. So does anybody remember what the data science pipeline is? How about anybody on the WebEx? People remember what you learned about the data science pipeline? Silence. So this is sort of the traditional diagram that kind of illustrates the workflow, the pipeline of doing data science. So there's kind of this ingestion phase, the munging or wrangling phase, computation analysis, modeling and application, and then reporting and visualization. So I think it's important to kind of talk through some of these. So data ingestion is kind of two components, right? It's partly about going out and getting the data from some other place, and it's also about data storage, like data management. And so that is a very important thing to think about when you're going into wrangling, because you want to know that you have worm storage. Worm stands for write once, read many. It's critical if you are going to be changing your data set, that there is some original version of that data set that remains unchanged. And that's because you might get FOIA'd, you might have to go back and recreate it, you might have to explain your process in an SOP or to a colleague to explain to them how you did the wrangling. And if you cannot retrieve the originally ingested data set, that is going to cause problems. I'm sure everybody has some experience with that, where you had like an Excel file and you made edits to it and then saved it, and then you went back and couldn't get the original thing back. So that's a very important part of the pipeline to be kind of sensitive about when you're talking about wrangling and munging. We're talking about transforming a data set. You want to be able to go backwards too. So this shows a unidirectional arrow, which is probably a mistake because you want to be able to retrace your steps, right? So then the next part after wrangling and munging is computation and analysis. What I would like to say is that there actually is quite a lot of analysis and computation that goes into wrangling and munging. So kind of showing them, depicting them as discrete things is, you know, a little bit limited. So one of the things that we'll see is that in order to make decisions about how we do the wrangling, we already need to know a little bit what kind of computation we want to do on the data set, right? So you could have a single data set and want to ask a lot of different questions about that data set, and it would lead you to wrangle it in different ways, potentially. So you already need to know a little bit ahead of time how you're going to do computation and modeling in order to wrangle effectively, or you have to have a high tolerance for re-wrangling after you've done it incorrectly the first time, which does happen. Okay, so what is data wrangling? Based on context clues of what I've already said. So somebody in the room suggests, sorry, what's your name? Gina. So Gina says taking the originally ingested data, doing some transformation, some processing so that it's kind of ready for analysis. So I think that is definitely one of the tasks associated with wrangling. So part of it is this kind of transformation, you know, taking it from like some initial state to some other state that is ready for analysis. I would suggest that, you know, there are a lot of kind of components of wrangling, and it really sort of depends on your data set. I think that, you know, this is sort of the definition that you find if you look on like Wikipedia or Stack Overflow and you ask like, what is data wrangling? They'll say like, it's about gathering, extracting, cleaning, and storing data. But from my perspective, it's really more about asking questions. You know, it's being able to do like diagnostics on your data. So figuring out what the problems are and what needs to be changed and what questions you want to be able to ask of your data set. So your boss is saying like, we need to be able to take, you know, a snapshot of the database and figure out how many hours people are spending doing XYZ, or like how many times we had somebody request XYZ, or, you know, something like that. You need to kind of know what questions are going to be asked, and that informs wrangling, right? So I think that, you know, it's useful to think about the mechanics of data wrangling, which are, you know, gathering data, doing those transformations, extractions, cleaning, imputation, and then storage. But I think that you want to kind of keep in mind that sort of high level definition also, which is that it's about kind of being able to ask questions and find answers in the data. So here is a quote from Bradley Wojtek. He says, in my opinion, the trick of data munging is the most surprising skill any data scientist must learn. It seems so innocuous. You just need to get data from one data set to match up with or in the same format as some other data set. For anyone who doesn't deal with a lot of data, it's simple. Data is just data. That is, data is some spreadsheets with numbers in ordered columns and rows or bits on a computer or something. But for anyone who's worked with lots of data, you know how nightmarish getting data from disparate data sets into a workable fashion can be. So another way to say this, so this is written by DJ Patil, who's now the chief data scientist of the United States. So he wrote a book called Data Jujitsu. So in his estimation, it's 80% of the work is data cleaning. And some people, even suggest that it's more than that. It sort of depends on the data that you work with. But I think that this is that part where I told you at the beginning, I want you to be able to understand and appreciate and explain why wrangling, why cleaning takes up so much time. So he says, it's impossible to overstress that 80% of the work in any data project is cleaning the data. If you can come up with strategies for data entry that are inherently clean, you're much better off. But we work in a field where that is probably not going to happen anytime soon. And we are sort of, blessed/cursed with the data that we do have. And in a lot of cases, I don't know which agencies you all are working with, but in a lot of cases we have large quantities of data that actually have a lot of sort of hidden potential, but there's this sort of challenge of kind of getting it into shape for asking the kinds of questions that we want to be able to ask. So this is sort of a joke in the data science community. This they say, this is big data Borat. In data science, 80% of time spent prepare data, 20% of time spent complain about need to prepare data. So that 80-20 ratio is something that comes up a lot in discussion, enough so that now it's sort of like a running joke. But I do think that, when you are planning out a project, it's very important to take into account how much time wrangling is going to take, and also to think about the fact that once you've, it's not sort of a, linear process. You do some cleaning and then you probably have to go and do some computation. You might have to go back and do some wrangling again. So why do we need data wrangling? So for this, I think it would be useful for you to start thinking about some of the wrangling tasks that you actually are already doing at work. So not thinking just kind of why do we need data wrangling in general, but thinking about your specific context, the data that you're working with. So I actually would be interested to hear from some people, who are willing to kind of talk a little bit about, maybe you could say what agency you're from and the type of data that you work with. And maybe you could talk about, some of the wrangling tasks that you need to do or that, are done with that kind of data. Anybody want to volunteer? Mm-hmm. Hi. I wonder, maybe if
I'm George with NOAA Fisheries. I work with fisheries management data on this, primarily logbooks, fish dealer receipts, and a couple other in our scientific observer data. And so our big, some of the big data wrangling needs is to deal with cleaning up data because they're self-reported data. So there's often outliers due to typos. We also need to tie together lots of these different threads of data to do something like reporting on revenue for a fishing trip. It's like 3 different data sets usually, sometimes more, that need to get merged to produce something like that.
Okay, thank you. Other folks in the audience, people on WebEx are welcome to jump in here too. So I guess I'm curious, like, in particular, if some of the tasks that you're working on are kind of like what George suggested, like some of these kind of complex aggregation tasks. You also mentioned cleaning up manually entered data, which I think is, I expect is something that a lot of people are struggling with also. Maybe things like entity resolution tasks or deduplication tasks are sometimes part of wrangling. Do we have anybody on the WebEx who has any suggestions? Not yet. Maybe I'll give you a minute to think about it. George, could you pass the microphone down? Thank you.
Noah as well. I work with satellites, particularly a search and rescue satellite program, and I think data wrangling would be useful for me because we're bringing a new development system online, and there's various types of data that we're getting in and kind of just trying to make heads or tails of what we're looking at. So in order to be able to do analysis and compare those, you're going to have to kind of put them all into some box and say, this is what you see here. And so data wrangling would probably be able to sort through that data and put it into a form that's much easier to be analyzed and even use in kind of like a real-time analysis for troubleshooting and trending.
So can I ask, what is the kind of volume of the data that you're dealing with? You said it's satellite data. Is it streaming, or is it kind of like snapshots?
Most of it is streaming in, and there's various streams actually. There's the rawest of the raw data, which is coming in real time, and every minute you're probably getting hundreds of data points. And then there's solution data where the ground systems that are remote are actually making solutions from those raw bursts and then sending those, and those you might get only 10 or 20 a minute.
Gotcha.
But it's still all coming in there and being aggregated in one central place. It's just a matter of how to deal with it.
I gotcha. Yeah, and one of the other things you said was that you have a new system, like a new database. So I think that a lot of people end up having to struggle with wrangling tasks that involve taking data from an old, like, legacy database and making it make sense with the new database that's been launched, and inevitably, like, the database schema are different enough that kind of automated joins are very difficult. And it's, people kind of continue to ask questions that kind of force you to span, maybe like 10 years, and there's, 5 of the years are in the old system and 5 of the years is in the new system. You have to figure out how to tell sort of a consistent story. And wrangling is, one of the things that, can be useful for finding a way to sort of systematically, ask those questions. Are there other folks? I see you typing, Carl. Audio isn't coming through. Oh, I see. Oh, well, I think that it's like they're muted, right? So all the people in the audience are muted. So they'd have to type their question, I think. Oh, okay, cool. Well then, yeah, I'll be quiet while our person types up their question or their answer. I guess the main thing that I want to try to figure out is, like, what are sort of the main wrangling tasks that are kind of interesting to the people in the audience. So it sounds like aggregation. It sounds like for you it's going to be a little bit more like sorting maybe, or kind of aggregation, like group by kind of tasks, so that you can kind of quickly summarize data sets and maybe just kind of focus on certain features, certain columns, and not kind of look at everything at once. So sometimes wrangling is really just about kind of filtering, right? So that you can actually look at a digestible amount of data at once.
So we've got Justin Reed. He's a contractor for NOAA, NOAA's NCEI in Asheville. And for his project, he works with XML metadata for weather, climate data granules. He uses XSL to wrangle XML metadata into a form that follows by an international metadata standard.
Okay. So that's sort of an interesting use case because, you know, you're sort of in a situation where your wrangling needs to kind of comply with a known standard, which means that the controls, you know, will be tighter, and your scripts will have to kind of make sure that they export things that kind of comply with that that standard, so that people in the field will be able to, you know, process it. I think that. You know, I think that like this is not a sort of surprise answer, that the reason that we need data wrangling is because real data is messy. You know, so data never comes to you in a form that's, you know, ready for analysis right off the bat. There's always something that you need to do, and so, in some cases it's a lot more work than in others. So there's this kind of paradigm of, you know, what the impact of problematic data can be. So, you know, in the context of like prediction and modeling, you know, having a bad model, you know, picking the wrong algorithm, picking, you know, the wrong predictive technique is bad because, you know, you can ruin, you know, very nice data with it. But the more likely scenario is that, you know, you have data that is problematic and it poisons your model. Either way, you end up with garbage results. So there's this kind of critical need to ensure that the data that you're using doesn't pollute any of the analysis that you do. Do we have somebody else jump in?
We have Jeff Adams, who works for the NOAA Fisheries Office of Protected Resources, and he wrangles a lot of vessel data for monthly reports into a database. And what he needs to do is aggregations, create keys, eliminate duplicates. He does this in his Postgres database. It takes a while, because he's typically importing about 200 million records a time per month.
So that's a lot of volume. That's a lot of ETL. I think that, but what I hear is that you know, entity resolution and deduplication are an important part of that. I think, you know, generally that's one of the things that you see as the volume of your data increases, the likelihood that there's duplication or, you know, multiple references to a single entity, that sort of increases too. And I think in those cases, a lot of the work is trying to resolve, you know, those multiple references that you know that they're all, you know, these blips, these flares all correspond to the same entity, being able to say that, or that they correspond to the same, you know, business, to the same, you know, cell tower, being able to kind of resolve that is really important. And it's not the same thing as removing duplicates, because if it was as easy as removing duplicates, you could just do it in Excel, right? And because Excel has a remove duplicates function, and it just looks for, you know, exactly duplicated, you know, rows, and it gets rid of duplicates. The problem with that is, you know, if they're not exact duplicates, or if multiple instances matter, you know, like if you want to know that it happened twice, you know, the count is important, or if there's a slight variation, you know, across the way that they're recorded, that gets tricky, and you need sort of more sophisticated tools. And I think actually Postgres is a pretty good tool. So it seems like, he's already kind of using some of the tools that I'm going to kind of end up pointing people to. So we said this a little bit already, that we need data wrangling because real data is messy, and wrangling is what we do to make our data usable for computation. And this is a quote that always sort of makes me chuckle, but it's from Charles Babbage's memoirs. He says, "On 2 occasions I've been asked, 'Pray, Mr. Babbage, if you put into the machine wrong figures, will the right answers come out?' And he says, 'I'm not able rightly to apprehend the kind of confusion of ideas that could provoke such a question.'" So, this sort of notion that people think that computers are magical, right? That they can somehow magically get to the solution even if you don't give the right input is a problem. And I think that it's not as much of a problem as maybe it was for Charles Babbage in 1864, but it is definitely a problem that persists. And I think that there are a lot of kind of even famous cases where data was used in a way that it wasn't meant to be used, or incorrect data was used, like the Google flu kind of fiasco. Google used these data sets to try to predict the flu epidemic, and the first year their predictions were really good. In the second year, their predictions were off by an order of magnitude, and it was incredibly embarrassing because people started ramping up for this enormous epidemic that didn't happen. And so the input does matter. Computers are not magic. So it's actually, I think, kind of useful to think about kind of all of the different places that error and breakdown can happen in the sort of complicated version of this pipeline. So this is a list of a lot of the different tasks that we've been talking about already. We've been talking about extracting the data that's relevant from the numerous columns and rows that are coming in and trying to pick what's relevant. We're talking about collating and aggregation. We talked about joining multiple sources together. We talked about deduplication a little bit, and record linkaging. So these are kind of anecdotal as far as I can tell, but they sort of have this fairly good correspondence with my experience of the kind of percent data loss or error injection that happens for these different phases. And you can see that some of them kind of have the potential to inject a lot more error than others. Sorting, so long as you're not being too reckless about how you're sorting, is not likely to inject a lot of error, whereas data extraction has the potential to inject a lot of error, maybe as much as 10 or 12%. But I think that the main thing to think about is that no matter where the error is injected, that it propagates, right? And that propagation is exponential. So whatever error you inject kind of early on, at the ingestion phase, if in the pipeline, if that error kind of continues, it propagates and it kind of creates worse and worse effects. So catching things early is an important thing if you can do it. So catching errors. So this is going to come back to data wrangling is a lot about asking questions, right? So catching errors is a lot about knowing what errors to look for and what kinds of errors you expect to see. So far, when I asked you what kind of data wrangling tasks you do at work, you sort of talked about what you actually do to the data, how you need to transform it. We haven't talked a lot about the kinds of errors that you see. So I would be interested to hear from you. George mentioned that some of the errors are errors that come from manual data entry. So, so that's one that I think probably some people will have some experience with, where maybe like a company name is spelled a bunch of different ways, but actually references a single entity. Misspellings, different like variations on company versus co versus LTD. Those kinds of things can be problems. But that's like kind of a very narrow subset of the kinds of errors that you probably see. So I'd be interested to hear about the other kinds of errors that you frequently encounter in the data sets that you work with. You want the microphone? So you have a lot of Unicode?
Invalid Unicode characters, right? So not all data sets that claim to be UTF-8 are actually UTF-8.
Right, so you end up with something that's like ASCII or UTF-16 or just like total garbage.
No, you can have invalid UTF-8 characters that cause exceptions when you try to read them, because the bytes don't actually translate to a valid UTF-8 character.
So you can't decode them. Yeah, so like, an example of this is, a lot of times you'll find things like characters like that, like accent characters over an E or over an I or something, somebody's name, or some of these, sometimes like different languages, you'll find errors injected from there.
Trying to read binary data where there's been data corruption.
Data corruption issues. Okay. So yeah. So those are two different things. And so some people may be coping with data corruption issues, and other people might be coping with translation issues. So if you work with data that's kind of traveling between languages, you actually can find errors when things get translated. The codecs, when they get translated from one language to another, you can find error that way. Other kinds of errors that people encounter at work?
We've got reporting errors and incorrect units of measure or the wrong currency. We've got missing carriage returns separating two records in a CSV file.
Oof. That's a tough one. Yeah. Yeah, so I think the units thing is like definitely a pet peeve. When the units are different, or there's variation, or there's no units and you don't know. But yeah, the carriage return ones are tough in CSVs. Those are tough to fix in an automated way. Other kinds of errors that people encounter a lot at work? Here is a kind of list of some of the categories of error that I tend to encounter. So some of these are like corruption issues, like you mentioned, things where there's some kind of breakdown in the actual conveyance of the data that introduces corruption. This also happens a lot with OCR, ocular character recognition. So if you are taking, for instance, like a PDF document that's an image and trying to extract the text from it, you can expect a lot of transcription errors from that. Typos and misspellings also kind of fall into this category of transcription errors. So that would be something like, Washington or Mississippi spelled incorrectly. So another kind of category of invalidated, and I think somebody on the WebEx sort of was pointing to this, data that is not valid. So, maybe like a phone number that's not a real phone number, or an age that's not possible. The data set that I'm working with right now has a lot of events that supposedly happened in 1910, which I think is unlikely given the context of the data. And I have no way of knowing kind of what the actual correct date is. So those are some of the things that I think we probably encounter. So invalid data, so you're kind of something that's out of range, that's not like a valid number, or the structure is not expected. We've also got problems with incomplete data sometimes. So this is where maybe there's just a missing value. You know, this actually I think happens a lot with manually entered data because it sucks to enter data manually, and so there's an incentive not to. So in a lot of databases where you have the option to populate a field or not populate a field, people will elect not to populate that field, and you can end up with missing data that is sort of, you know, problematic for modeling, for analysis. Encoding error, you know, that's something that came up too. So trying to use Unicode or proper encoding and decoding, that is something that I struggle with a lot with the data sets that I work with. Another kind of error that's sort of a different class of error than what we've been talking about is inaccurate data. So if you are working with a data set that has, you know, names associated with genders, this sort of example of you know, somebody with a kind of an ambiguous name, you know, Sam could be a man's name or a woman's name, and you know, you could have some sort of heuristic that guesses, or you could, you know, have a person who's guessing the gender from a name, but there are going to be errors sometimes if there are names that are kind of ambiguous. And prediction error is something that you start to deal with a lot in machine learning because, like I said, computers are not magical. And you know, if you try to do some kind of like regression with continuous dates, let's say, and you're making predictions about, like, you know, characteristics of a president, the computer doesn't know that there was no U.S. president in 1865, right? So it will give you this sort of prediction, even though that's not a valid thing. But I think that what we want to sort of talk about is the difference between syntax errors and semantic errors, right? So syntax errors are immediately identifiable. These are things that, you know, you're looking through the data set, and when you see it, you know right away that it's wrong. Like, you cannot be 225 years old, you know, or you can definitely tell that there's some sort of corruption that's happened. These are things that are easy, you know, in the grand scheme of things, errors that are easy to find. They are a problem, and they do need to be cleaned and dealt with in wrangling, but they're very different from semantic errors, right? And so semantic errors are the really dangerous ones because they're not always obvious. And this is something like, you know, only a person would be able to see. So the date, you know, the different metrics thing has come up already. One of the ones that I find a lot is this date time inconsistencies. So like 12/10/07, you don't know what that is. Like, which one is the day, which one is the month, which one is the year? It's not obvious. You know, it could be any of those, right? Any of those could be a valid date. Any of those could be a valid month. Any of those could be a valid year. And until you see another example of the date that sort of constrains what the options are, you don't know what the answer is. And so wrangling sort of needs to take into account the difference between syntax errors and semantic errors. You also have to kind of, through practice, get good at identifying things that might look like gibberish if you're kind of new to data analysis, but if you are kind of more experienced, you kind of know what to look for and are used to seeing certain things. So does anybody know what this is? Yeah, so this is a timestamp. It's a date. It's in milliseconds, and I think it's milliseconds since November 14th, 1970. So to me, that is like a valid timestamp. But I think, if you saw that listed in a date time column and you didn't know what you were looking for, that might be, something that would look like error. So you also need to know when something's not an error, right? So these are kind of the 6 pillars, let's say, of data quality. So we've got validity, accuracy, completeness, consistency, uniformity, and timeliness. I'm going to say a little bit about each of those. So these are sort of our targets, right? This is what we're kind of aiming for in wrangling. Some of these will be more important to us given our use case than others. So validity is about the data conforming to a schema. So this is going to be really important. Validity is really important if you need to be able to join things across data sets, right? You need to kind of know where the schemes are and where the spine can be. Accuracy are things like spot checks, making sure that if you just kind of pick a random sample, that you're not having inaccuracy issues. As for completeness, you want to err on the side of including as much data as possible, because statistically that means that errors that are there kind of have less influence overall, right? So for consistency, you want to make sure that data are matching. So this is an example of like, the date times. You want to make sure that all the date times are, formatted in the same way. You want things to be in the same units and encoded the same way. And then also, you need to know that the data has not sort of outlived its usefulness. And so wrangling needs to happen quickly in addition to all of these other things, right? So I'm going to come back to this notion that in practice, wrangling is mostly about asking smart questions. So questions are going to be like, what are the problems with this data set? Where are the problems with the data set? Is it, is there a certain chunk of it that's corrupted? Is there a certain column that tends to have a lot of error that you need to kind of plan to address each time you do ingestion? Is there a subset of the data that is manually entered that tends to have a certain, kind of problem? You want to know how many problems there are, how many different kinds of problems there are, and how to address each of them. You need to kind of think about what sort of fix makes the most sense. So if you have a lot of missing values for a certain feature, what is the best strategy to deal with those missing values? How is that different than how you would handle like a transcription error or a semantic error? So we talked about this a little bit before about repeatability, right? So we are doing science. We want our fixes to be repeatable. And I think this is really hard if you're kind of moving from a traditional data analysis kind of technique to data science. You're not maybe always used to creating these processes that are repeatable, but we don't want to just edit things in Excel and then resave the document, right? Like that is not repeatable. The original data is not recoverable, and so we need something that's sort of better than that, right? And then most importantly, you want to think about automation. So you want to think about how can I automate whatever I'm doing now so that I never have to do it again because it's horrible. And you actually can, so you should be thinking about, which of the things you're doing can be part of a regular process, a regular cleaning pipeline that the data goes through each time it comes to you. Do you have to do this on a quarterly basis, an annual basis, a weekly basis? Be thinking about that. Think about the parts of this that you can take the human out of, the parts that you can automate so that you don't have to do it every time. And I think that is sort of key to breaking these problems down in practice. So I would like to hear about the kinds of tools that you're using now to do your data wrangling. So somebody mentioned Postgres. which I think is great. If you know SQL, Postgres is a terrific and fast tool for doing a lot of wrangling tasks. What are some of the other tools that people are using? That's a good one. I definitely have a personal affection for Python. So do we have some people chiming in there on the WebEx?
We do. There's the Python scientific libraries.
So like the SciPy stack?
Yep. Command line tools, XSL Eclipse IDE.
Okay. Go ahead.
Now this is from Jeff Adams. He was using the Postgres. He uses it for storage, but he cleans the data via Python so he can use faster import techniques. And all the records need to be cleaned before using the copy command.
I gotcha. So that is much faster, for sure. Other tools that people are using at work? Staff? So probably similar kinds of things, you know, the SQL-like kind of like commands that, you know, do look for, you know, missing values and run updates and stuff like that.
We've got R in RStudio.
R in RStudio. R is a really useful tool for data wrangling, and actually one of the punchlines about Pandas is that Pandas is really just trying to replicate the concept of an R data frame. And it does it really well, and it's really useful if you already know Python and you like to stay kind of in Python, or if you need to build some kind of tool, being able to access a data frame object natively from within Python can be useful. But yeah, our data frames I find a very useful tool for wrangling tasks. I noticed that nobody has sort of said like the elephant in the room, right? So I actually don't hate Excel. I'm just going to like put it out there that I think Excel is useful. And in fact, when I first started working here, I got this like really nice computer on my like second or third day, and I was using it right away. And I had like Python and R and Postgres like right from the get-go. But I did not have any of the Microsoft Office suite. And it was really, like, I think the first time that I've ever had a computer that didn't have those tools. And it was really fascinating to think about, like some of these tasks that I just kind of got used to using Excel for, figuring out how to, change my workflows so that I was just doing them kind of natively in R or Python or something. So actually, I'm not going to, talk smack about Excel. I also don't work for Microsoft, so I don't feel like I have to say like a lot of nice things about it. But I do think that I expect that most people here as in the Department of Commerce, are using Excel to do their wrangling. And so with that kind of in mind, I wanted to sort of talk about the kinds of things that Excel makes easy and the kinds of things that you cannot do with a tool like Excel that would kind of motivate you to branch out to a broader suite of tools. So actually I'm going to make you do some wrangling with Excel. So what I'd like you to do is you can go to this GitHub repo called Hathor. So this is one of the ones that was distributed via the email last week. So if you have that email, you can click on that link, or you can just you can go into GitHub and search for Hathor under the user Rebecca Bilbro, which is my repo. So if you have Git and GitHub and Python on your machine, I would encourage you to go ahead and clone that repo if you haven't already. So the way that you do that is you just type git clone and then put in the URL that shows up on the Git repo. So you have to click. Git just changed, or GitHub just changed the way that they do the repo pages, which really irritates me because now you have to click a button in order to get the clone link. So I've provided it there for you. Basically it's just the same URL as before, but it has a .git at the end. So you'll git clone and then paste that in to your command line and then change directories into it. So a lot of people who are still kind of getting used to using Git kind of forget to actually enter the folder that they've just cloned. So you want to git clone Hathor, cd into Hathor, and then open up a IPython or Jupyter Notebook. So once you get to that repo, so if you have access to the command line tools, you can do it that way. If you do not, you can actually just download the data set directly. So it's in the data folder. So you go to the data folder, pull down that Movie Lens data set, and open it up in Excel. And so I want you to, so you remember data wrangling is about asking questions, right? So I want you to try to answer these 8 questions. So I'll leave them up on the screen while we do this exercise, but they're also listed in the README in the repository. So the 8 questions are, what is the oldest movie in the list? What's the newest movie in the list? How many unique movie titles are there? Which titles are the ones that have been repeated? Of the repeated titles, which are remakes and which are duplication errors? So here we're getting at different kinds of errors, right? How many movies overall were released in December? So now you have to figure out how to parse the date time, right? Which movies contain an animal in the title? And which movies have a title that's longer than 5 words? So, this is an exercise. I realize that we don't work with movie data, but I tried to pick the kinds of tasks that are similar to some of the tasks that we have to do, that, things that force us to identify different kinds of errors, things that, help us identify, duplication or entity resolution problems, things that have to deal with how long a field is. Sometimes, like if you're working in Postgres or a database tool like that, there are problems if you exceed the character limit on a field. So like being able to identify something that's a title that's too long that you might have to abbreviate. Being able to parse date time is another kind of critical thing that that a lot of us probably have to do for the data that we work with. So I am going to turn off my microphone for a little while, and we'll sort of circulate around the room, and also we'll stay here on the WebEx as the questions come in. It's U item. Here, I can try to bring it up here. Yes, u.data, or u item or u data or something like that. Sorry? Yeah, I think it's u item is the one that we want. What does it say in the README? So u data then. Yeah. So the data set that we want is that u.item. Share. So it's in the data folder here. U.item has a numbered list of movies along with release dates and links, and then a series of binary. So it's about 2:15. So let's take maybe 10 minutes to work on this, and then we'll do a break also. So we'll come back. I'll turn the mic back on at 2:30, and we'll resume then. So we're about at 2:30. Here, folks in the room, do you need a break? 5-minute break, maybe? So let's do 5 minutes for people who need to take a break and stand up. And we will come back at 2:35. And then I'm going to quiz you, see what all the answers are. All right, we're going to get started again here for our second half of the class. So how'd you all do with your questions? How did it go with opening the file in Excel? So it's not, it's not as smooth maybe as opening an Excel file in Excel or a CSV file in Excel. So what did you have to do to get the file to open? Can you grab the mic?
You can change the extension to .csv and then open that up in Excel, and then there's an option to open that up and then specify the delimiter as the pipe.
Okay. Did other people try other things to get it to open on their machine?
Just for the Excel opening a file, you can just say, show me all files, and then you can open it to that, and it brings up the same, how do you delimit it or use the fixed width.
Mm-hmm. So yeah, I think, one of the tricks is the extension, but also kind of identifying that the delimiter is a pipe, which is, somewhat not expected. If you're used to comma-separated files. So, right away, you kind of have to figure out how, how the file is structured before you even can start answering some of the questions. So were some of the questions pretty easy to answer using Excel? Which ones were the easy ones? Yep.
Just the early and the latest ones, you could just sort by the date.
Yep.
Pretty easy.
So yeah, Excel is really nice for ordered things, so, assuming all the dates are in the same format, it's, makes it pretty easy to sort, from smallest to largest, from largest to smallest. So that's convenient. It's also, useful for sorting things like alphabetically, so some of the kind of, basic sorting tasks are pretty easy to do in Excel. Other things, people from the WebEx chiming in about tasks that they found easy or hard relative to each other. The pipe delimiter.
It was easy to find the duplicates in Excel because it has a find duplicates feature.
Yep.
But it was hard to find the specific ones. You had to use conditional formatting to color the duplicates. With Excel filters, it was easy to find the ones that were released in December. And you could create a formula to report the number of spaces in each text string. So it's easy to find the ones with titles longer than 5 words.
With long titles. So what about the differentiating between duplication errors and remakes? That one's, is a little bit trickier because that starts to, get at things that are a little bit more like semantic errors. But I think even there, there are some technical things that you can do. So what I've done, if you go into the notebooks folder, you can open up the IPython notebook file. So you can either open this up in your browser or you can actually launch it. If you want to manipulate it, you can launch it through your command line. so this was sort of the process that I used for answering all of those questions using Pandas. You know, and as you can see, you know, some of the things like, you know, being able to sort things, you know, is sort of comparable to using Excel. Whereas other things are a lot easier to do in Pandas. So, you know, if we're asking something like, what's the oldest movie in the list? The way that I've done it here, you know, it takes a couple of lines. You know, first I have to go through and do some parsing. You know, I tell it that the separator is going to be a pipe. So that's part of the kind of initial setup of the data frame. So this is you know, we're going to revisit this kind of formatting. But I wanted to point it out to you sort of in the wild so you can see. So you know, I tell the script what to look for, where to look for the data set. And then I tell it what columns to expect, and to expect the pipe as the delimiter. I also tell it only to look at some of the columns, because some of the columns are not going to be useful. And I also pass it the encoding scheme so it knows how to parse. I also force it to use the movie ID as an index column, which is useful because it's unique. It's a unique identifier, which is helpful when you get to things like entity resolution and deduplication. So we'll kind of go through this in the slides later, but you can kind of see sort of how the data frame manipulation starts to work in Pandas. You know, so you can use regex if you're used to using regular expressions. You can do regex in Pandas, which is what I've done here, to get rid of some of the stuff in the title that I didn't want. Using sort values, this sort of dot notation, where you say data frame ds.sort_values calls the sort values method, and you pass it the column that you want. So you ask, and you can ask for just the first result. That's what head paren 1 is. So that gives me the oldest movie, and basically it's the same method to get the earliest movie, but you actually force it to put things in ascending, or to put things in descending order. So you pass it ascending is false. So if you read Python regularly, you know that what that means is that sort values is automatically going to assume that you want ascending values. If you want them to be descending, you have to specifically request that. So the default parameters are to set sort values at ascending. But if you set it as false, then you can get the most recent movie in the list. In order to get the unique movie titles, you know, I first got the length. So to get all of the titles is just length. So you ask for the length of the data frame column. So you can see this notation where we've got df and then brackets, and we pass in the column that we want in quotation marks. In a lot of cases, you can also use dot notation to access columns. So you'll see a little bit of that in some of the lower lines here. But here we ask for the length again, but this time we use dot notation to call the unique method in Pandas, which looks for unique titles. That gives us a count of unique titles, but it doesn't tell us specifically which ones have been repeated. So in order to do that, I actually created a kind of subset of the data frame called repeated, and I ask it to look in the titles, find ones that have been duplicated, and to sort those. And then I print out repeated to get all of the repeated titles. So from looking at this, we can see, you know, if you watch movies, you probably know, you know, some of these are maybe familiar to you. Some of these are obviously remakes, And some of these are duplication errors. So, for example, like Sabrina here is a movie that originally came out in 1954 and then was remade, you know, in the 90s. So that is a remake. But something like Sliding Doors here, the charming Gwyneth Paltrow movie, is probably a duplication error, right? Because, and we can tell that because the date is the same, right? So that's probably referencing the same movie. So we can use information like that to figure out how to differentiate remakes and duplicates. So that's kind of how I do, that's how I proceed. So I proceed by kind of figuring out how to classify errors, which, you know, ends up using both the title and then the release date to disambiguate. And then the remakes basically makes use of the duplicate subset that we've already made and then drops all of the ones that are duplicates, which gets us the remake. So these are all of the ones that had the same title but different release dates, right? So we're going to kind of operationally define those as remakes. So then to access information about the date, we're going to use the fact that Pandas has this very nice tool for parsing dates. So you can actually call Pandas, which I've shortcutted. I tend to alias things in Python. So you can see at the top here, when I imported Pandas, I imported it as PD, which means that down here where I say pd.readCSV, I'm actually calling Pandas, the Pandas method read CSV, but I've aliased it so I don't have to type out all of Pandas every time. So here, I'm accessing the Pandas datetime index method, which is really nice because it lets you break things down into year, month, and day. So now all I have to do is get the length of the month, length where month is 12. So the double equal sign, again, in Python is an inequality test. So it tests if the month is equal to 12, and if it is, it counts that in the length of that subset of data frame column. So there's 38 that came out in December. Testing whether there are animals in the title, so that, you know, is a little bit of a, you know, that's a semantic thing, right? So what counts as an animal? You know, so the way that I decided to address that is by building a string, you know, or building a list of strings that have some animals in them, and then using this sort of dot notation to access the title column of the data frame and use the string method string.contains to look for this pattern that I've built, which is a combination of these animals and this pipe, right, that we've already identified as the separator. So using that, I, you know, kind of generated this sort of arbitrary list of titles that have some of the animals in them. Of course, there will be some issues, like, for instance, Delicatessen, which is not a charming movie, but a good one, has cat in it. So we've incorrectly identified Delicatessen as a movie that has an animal in it, which I guess if you've seen it, it kind of does have an animal in it, but not the way that you're expecting. So anyway, this is not a foolproof method, but data wrangling is sort of about like hacking your way to something that kind of gets you closer to where you want to be, right? So asking this question about movies that have titles longer than 10 words, there's a bunch of different ways you could do this. In fact, there's a lot of different ways you could do a lot of these things, so I'm not sort of suggesting that this is the only solution, but I just wanted to give you all examples of how I would execute those questions using Pandas so you would be able to compare it to what you did with Excel. So you're welcome to kind of check those out a little bit closer. So at this point, I'm going to switch back to our slides. Yes. The date? So I use regex. Is that what you're asking, this regex parse where I clean up, so I strip off the date from the title? You don't have to, because if you use the datetime index method that comes with Pandas, you specify and it makes that guess for you. So it does very sophisticated date time type guessing. So that's one of the things that I think that Pandas is really helpful because it does very effective field parsing. So here? Nope, this is what you're talking about. I told it that it's a date. So I said release date is, I changed it to datetime format. That's what you're asking, right? So you asked me, like, where is the code where you specifically say that the column that release date is a datetime? So there's this, datetime method that's part of Pandas. So you can pass this column to that method, and it changes the format for you, so that now you have access to the specific components of the datetime, year, month, and day. So I'm going to switch back to the slides here. And, okay. So I want to talk a little bit more about the, oh, go ahead. Yes, so yeah, I'm going to show you some of these methods here. I just wanted to kind of show you in the context of what we've done already, but yeah, so I'm going to kind of go through. I think the data type parsing is one of the advantages of using something like Pandas. There's actually, if you're interested in like very specific data type parsing, especially, different versions of datetime, there's actually another Python package called Messy Tables that I would strongly suggest people check out. It actually has a lot more options for different kinds of data type parsing than Pandas does. But Pandas is really good because it has this sort of, hierarchy of how it guesses. Like it guesses, the most sort of, or it does this test where it looks for the most narrow things first, and it moves then to general. So, if it doesn't fit some sort of narrow criteria, it goes on, it loops, it goes on and guesses the next, most specific thing and continues down the line. And I think that, at the very end, if it doesn't fit any other criteria, it guesses that it's just a string, right? But that's a lot better than just right off the bat guessing that everything is a string. So it'll first try to say like, okay, is this a Boolean? Is this an integer? Is it a float? So it asks sort of these specific, questions, which ends up being really helpful because then you don't have to cast the type every single time. But a lot of times, if you have sort of specific things, it might guess wrong. And so one of the things that you saw, or that I was going through it quickly, but you saw me recast something as an integer. So I think it's because like the default was to cast it as a float, and I wanted it to be an integer because I wanted to do like integer arithmetic on it. So it ends up being fairly easy to just recast something as a different type if Pandas kind of makes the guess wrong initially. You can also pass types at the very beginning when you just create the data frame. So from the very start, you can force it to use a certain type. which is really convenient if you already know the types that you're kind of dealing with. So I wanted to say a few of the things, some of these things are things that came up already that are good about using Excel. So I certainly don't want to suggest that Pandas is going to be like a replacement for using Excel. I think Excel is useful for data presentation and for sending data to other people, especially if it's not too big of a data set. It also makes kind of simple row and column operations like filtering and sorting, like we talked about, like sorting by date, was pretty easy. It's basically, it's no easier to do that in Pandas than it is in Excel. It also kind of comes with all these built-in things now that it didn't, 15 years ago when you had the first version of Excel was very bare bones. But now it has a bunch of kind of fancy things. You can do all of these charts. You can kind of plot things out. You can make graphs. You can, and then if you kind of are into advanced techniques, you can build these kind of conditional, nested conditionals, formula that help you get at the questions that you're asking. And then there's pivot tables, which I feel like is increasingly, I think, being taught in college classes, because I'm seeing a lot of people who are kind of able to use pivot tables to do a lot of kind of aggregation queries on their data sets. So pivot tables is clearly gaining some popularity as a data analysis tool. But there are obviously some limitations. One of them is the fact that to do complex operations, you have to build these incredibly complex nested formula with multiple conditional statements. Another big problem is that I think Excel kind of encourages these sort of one-off corrections. So if you're reading an Excel file and you see a typo, it's really hard to just not fix that typo, right? But the problem is that those things are not repeatable, and what you want to do is kind of build this pipeline where the data kind of flows through and it gets transformed and cleaned up, so that anybody could do it, anybody could repeat it, and so that you don't have to keep doing that job forever, and you can move on to doing more kind of interesting analysis, right? So the other problem is that you can introduce error when you're doing, manual edits in an Excel file. So the aggregation tools are somewhat limited. The visualization tools are fine, but they're not super slick. So if you want to make something really fancy, you need to kind of use something like Tableau to make the very pretty pictures. But I think that one of the things that a lot of people encounter with Excel as a problem is that once you get beyond maybe 50,000 rows, when you're getting close to 100,000 rows, Excel starts to struggle. So does anybody have this experience of trying to open up a massive Excel file and it doesn't open? Or you open the file and you make changes to it and then you try to save it and it crashes your computer? So that is, I think that's a serious limitation, right? Probably for some of you who are dealing with, massive data sets, this is something that really kind of rules Excel out as being something that's really a practicable tool, right? I would like to suggest to you Pandas as an alternative to Excel for some of these things. But I will tell you right off the bat that Pandas, if you have a memory issue, if the problem is that you have 1 million rows and you want to use Pandas for your 1 million row data set, Pandas is not the right tool for you. And the reason is because Pandas holds all of that data in memory. So the advantage of using Pandas is that it's extremely mutable, right? So you can change any field, any row column, any place. You can make changes really easily. You can aggregate quickly. You don't have to use loops for the most part, which is really kind of surprising if you're used to doing traditional object-oriented programming. using Pandas is sort of surprising because in order to access the fields that you want to access, you actually don't have to do a loop most of the time. And the reason is because Pandas is holding all of this data in memory. The disadvantage of holding all of that data in memory is that it takes a lot of memory, right? And so if you have a lot of rows or a lot of columns, or if you're doing very, very complex aggregation tasks, Pandas is probably not the right tool for you. But it does make a lot of the things easier that we encountered with this sort of Excel exercise. And so what I'd like to do next is kind of go through a little bit about Pandas, some of the kind of main methods that I use when I use Pandas, and kind of go through those, talk them through just so you have some sort of exposure. And then, let's see, it's 3 o'clock. So I have another kind of workshop exercise where you'll get some experience getting to play with some of these tools that I'm going to show you to experiment with wrangling a data set for a machine learning task. So Pandas is an open source library that provides high performance, easy to use data structures and data analysis tools for Python. As I said before, Pandas is really, the advantage of Pandas is that it gives Python this data frame object that really was born out of R, and it makes you able to kind of execute those natively in Python. So some of the basic functionalities. So this is something that we saw earlier in the walkthrough. So to get Pandas, so if you have Anaconda, then you already have Pandas, so you won't have to install it. You won't have to pip install it or conda install it, but you will need to import it. So this is, for people who are already kind of used to programming in Python, forgive me, but if you're sort of getting used to, deploying Python packages within your scripts, you always have to have these import statements. So the import statement tells Python to go and look. It looks for Pandas, and the as PD, as I said, aliases it so that you don't have to type out Pandas every time to access the Pandas methods and classes, right? So for ingestion, this is, kind of basically the very bare bones version of ingestion. So, this already kind of assumes a couple of things. It assumes that you're going to use all of the defaults of the from CSV method. So pd.fromCSV, and then you pass it this path. So we're presuming that, what is the separator going to be? What are we guessing? Yeah, so the default separator is commas. Are we guessing that there's a header? Like, are there column names? Are we guessing anything about encoding? So these are the kinds of things that you should be kind of looking up. In fact, it might be useful if you open up a separate tab on your computer where you've got the Pandas documentation open, which I have here. Let's see. So you've got the Pandas documentation open here on the side. You can kind of easily search. So this is pandas.pydata.org. And if you go there, you can ask for just the documentation by clicking on documentation. So what's nice is that, in addition to a bunch of tutorials and information about installation, you have access to basically all of the documentation for Pandas. So you can ask, specifically about the read CSV method. And it will tell you everything here in yellow tells you what the default parameters are for this method. So you can see that it's going to assume that the separator is a comma. It's going to assume that there's no index column. So if you do have an index column, you have to specify which column that is. So, this is like a very long list of all of the default parameters. You can read about them here. This is kind of the general format the documentation takes. So it'll go through and tell you what it's going to assume about the data types. And what it's going to assume about, for instance, like how many rows you want to skip. So it's going to assume that you don't want to skip any rows. But if you know, for instance, that the first couple of rows are, documentation or something about your data set, like something about the provenance of your data set, then you can specifically say, skip those first couple of rows. You can tell it the number of rows. You can tell it to parse dates, which came up before. Somebody had asked about, can you even tell it to expect dates from the beginning? So you can actually parse dates right from the beginning using that parameter. So this is a good way to kind of read through these methods that I'm going to provide, kind of switching back and forth between looking at the documentation and the methods. So I'm going to switch back to full view here. Yes. So another nice thing about Pandas is that it actually works fairly well with Excel. So if you happen to have already a bunch of Excel files that are already kind of formatted, Pandas has a specific from Excel method. It's different from CSV, which is the one that we were looking at before. So it has a from Excel method that's sort of specifically attuned to some of the peculiarities about how Excel files are structured, right? So this actually makes it very easy to use native Excel files in a Pandas context. So to say a little bit more about the structure, so this DF that I have here stands for data frame, but it's an arbitrary name, right? So you could name it anything you want. You want to name your data frame something, probably something like sensical that has something to do with your actual data set. But a lot of times in the documentation, they'll use DF as kind of the default title. So when you're reading the documentation, you can kind of just attune yourself to looking for DF and knowing that that is just an arbitrary data frame name that you can replace with whatever your data frame is actually called. And again, PD is a way to call methods from Pandas, because I've aliased Pandas using import Pandas as PD, right? So a little bit more about parsing. So we talked about some of the things that we tried in this movie lens parsing wrangling exercise. One of the things that I tend to do is kind of define the columns in a separate line. So this is in terms of lines of code, it's less efficient, right? But in terms of documentation, it's better, because now, now somebody else who's reading my code knows explicitly which columns I've told Pandas to use as part of the data frame. So this makes it a lot easier for other people to read. So I say what the path is, but I also say what the columns are, and I pass them as strings, right? And then I use the useCalls parameter to pass it that array of strings, that list of strings. And then you can see the pipe separator there. So the separator, so sep is the way to pass the separator parameter. But you can add a lot of other things too. So you can, this is one of the things that I did in the Excel exercise. So I passed an index column. I said, read in the ID column as the index. And I did that because I knew that the ID column was unique. So that each movie had a single ID, and that the IDs weren't repeated. So I knew that I could recycle that as the index column. So a little bit more about data types. So if you are not sure what data types you get as the default, you can actually query Pandas directly And so whatever you've called your data frame, so remember here we're just calling our data frame df, but it's arbitrary and can be whatever you want. So if your data frame is called potatoes, it would be potatoes.dtypes, and that would return a list, a string, or a list of strings where the strings are data types of each column, right? You can also force types. So this is something that came up before. So in this second line here, we're forcing the C column to be an integer. So we can do that by passing C in parens or in quotation marks as a string into these brackets. So use this bracket notation, and then we use dot notation as type method and switch it from whatever it was before to an integer. And then the third one is this toDatetime method that we saw an example of. So here we're going to use the toDatetime method in Pandas to force column D to be a datetime, to be read in as a datetime, which gives us access to being able to parse it into month, day, year, which is really convenient. So a couple of other things that are useful for kind of initial exploration. These are sometimes sort of the first things that I do after I've imported or I've created a data frame and imported a data set in to Pandas. I sort of run these 4 things, and it's just kind of like a usual part of the methodology, right? So you ask it what the columns are, it gives you a list of the columns. And so you can use that to just double check that you brought in all the columns you thought you were bringing in and didn't, make any mistakes there. You can do, you can look for the values. So whatever your data frame is called, potatoes.values or df.values with the parens there because it is a method. You list the values for all of the data frame contents. You can also ask for the head and the tail. So the head is the first n rows, and the tail is the last n rows. So the default parameter for head and tail, I think, is 5. Is that right, Carl? Okay. So default, if you just say, whatever your data frame is called, df potatoes.head, it will just give you, it'll assume that you want the first 5, and it'll give you the first 5 rows. You can actually pass it a specific number. So you can say df.head and then pass it 10. It'll give you the first 10, or .tail, and then pass it 20. And it'll give you the 20 bottom rows of your data set. So that's really useful just to make sure that kind of everything came in the way that you were expecting. And then also periodically, as you kind of go through this transformation where you're changing things, maybe recasting types in different ways, maybe combining types, doing imputation, it's useful to kind of sometimes go back and rerun these queries to figure out how the data set is actually changing, so it gives you this sort of feedback about, what's actually happened to your data set. Okay, so I'm going to talk a little bit about doing math. You can do a lot of math with Pandas. There's more than just 4 math operations, but I wanted to be sort of selective and show kind of that there's a range, right? So this isn't meant to be exhaustive, and I would encourage you to check out the documentation for like the kinds of math that you probably want to actually do. So like if you need to like normalize or standardize or things like that, you can check those things out in the documentation. But if all you're doing are sort of simple operations, you can actually just add 2 columns to each other by using this bracket string notation where you pass in the column name as a string inside a bracket. And again, df is referencing the name of our data frame, right? So you can add those 2 things together. You can assign the value of their sum to a new column. So you can actually create another column that is the combination or, you know, the difference or, you know, the product, or the quotient, you know, so you can, you know, do these operations and then assign them to a new column. So this first line where it says df bracket c equals dfa plus dfb actually creates a new column in your existing data frame. So it actually transforms your data frame. So those are all things to keep in mind. You know, this is sort of the advantages of Pandas, like it's highly mutable data type, right? So it's very reactive to you, right? You can also do things like scalar multiplication, and you know, looking for averages or means. Pandas has a lot of these methods kind of built in. In fact, if you can even just sort of like guess that it probably has that, you know, so like, you know, for instance, min and max are other things that you can use just by using dot notation. So if you want to figure out the smallest value in the A column, you can say df.a.min, df.a.max, .mean to get the minimum, maximum, and, you know, mean for that column. You can see that I'm switching here a little bit between the dot notation and the bracket string notation. For the most part, they're interchangeable. There'll be some cases where one is more convenient than another. You know, one thing that you might notice is that sometimes your columns are named things that are protected types in Python. So like if you have a you know, if you have a column that's called str is a thing in Python. So if you try to use the dot notation, df.str.mean to try to take the mean of your column that's str, you probably will end up with an error, right? Because it will try to read str as string. And so in that case, you would probably want to use bracket and then the quotes to access the column if it's a protected type in Python. You know, you can also do things like compute covariance of different attributes. So there's a lot of built-in stuff. Again, I'm not trying to like illustrate all of the math that is possible, but I wanted to just show you that there's like quite a lot of range in what you can do. One of my very favorite things to do, this is like something that I use regularly, is the dot describe method, which gives you a full like descriptive summary. So if you're used to using like you know, what is it, Stata? You know, Stata has a very similar kind of describe tool. R has, you know, something very similar to this. It just gives you a table where it shows you like the quartiles, you know, the averages, you know, all of that. It just kind of spits out this, you know, nice block where you can look at everything. You can look at the standard deviation. That's super useful because you kind of just get this like quick snapshot of everything. How are we doing on time? We got 45 minutes left. Okay. So I'm going to talk a little bit about selecting and slicing. So there are these two kind of like close seeming things. One is the .loc method, and the other is .iloc. They do similar things and are sometimes used in similar ways. I think that they're both useful. So what I wanted to try to illustrate is like two different use cases. So using, here we're using loc to do label-based indexing. So we want to find all of we want to find a specific value in a row that meets some sort of criteria, right? So, you know, this is a case where we have a data frame that's called total, and in that data frame we want to look in the column that's called response, and we want to find the yeses and the nos, and we want to split them up because maybe like the yeses are going to get an email and the nos, we're never going to talk to them again. So this is a tool for kind of breaking those two apart. So we create a new object, yeses, and we assign that to the value of total, which is our data frame, total.loc, and then in brackets, we ask it to look in the response column for everything that has a yes in it. And then we do the same thing with the no's, but instead of looking for yeses, we're looking for no's. So this is label-based indexing. There's also integer row-based indexing. So this is if you want to reference columns not by their name, which is what we did here. The name of the column is response. Here, we're going to reference the column by numbers, by integers. Right? So if our data frame is called df, we can df.iloc, and then in brackets, if you want to get, for instance, a certain number of rows, you access that before the comma, right? So from 1 to 3 will give us the second and third rows for every single column. If we want to get all the rows but just certain columns, we do that after the comma, right? So this is, something that is not always intuitive for a couple of reasons. One, because of like where things go in the comma, but also because Python does counting a little bit differently. So if you're used to R, you think that 1 is 1, but in Python, 1 is 2. And also, the way that Python does like inclusive and exclusive in date range or numeric ranges is sometimes there's a little bit of thinking. But these two rows of code give you kind of a good template for how you would kind of numerically access columns and rows using Pandas. So the result of these is not a data frame. It'll usually be, for most of these, it'll usually be a Python array. If you want to turn it into a data frame, you have to PD and then turn it into one for a lot of the cases. That one? Right, so we are hunting for, yeses and nos, right? So we've got a data set, we have a column that's called response, and in some of the cases, it's going to be a binary, right? So sometimes people are going to respond yes, sometimes people are going to respond no. And we want to be able to split those up because maybe the people who are yeses, we want to send them an invitation, and the people who are nos, we don't want to bother them anymore. So we use this bracket notation. So total is the name of the data frame in this case, and response is the name of the column that has the yes or no. And then we use the double equal sign, which is an inequality test in Python, and we're searching for the string yes in the response column of the total data frame. So we're looking for all of the places where there is a yes and all of the places where there is a no. Does that make sense?
Yeah, that is the double equal sign. That's not the way double equal sign works. When you work with other Python. Yes, in Python.
You can actually use strings. Yeah, so Python will do equality tests with strings just the same way it would with numeric values. So that's the thing that's not native to Python. And I'm glad you pointed that out because I think that's sort of the thing that's hard about kind of getting used to Pandas. If you're a Python programmer or an object-oriented programmer, you're sort of used to building loops, right? So you're used to like checking each time, going through each instance with a loop, and looking for like maybe doing a where or doing a loop like for, but Pandas has all of this in memory. So it doesn't have to do that. It actually can use the .loc method to look through the entire column and log all of the yeses and all of the nos. It would work, I think, yeah. Yeah, so starts with would work. So that should work, right? Yeah. Yeah. So you would have to tell it that it's looking for a string, but yeah, that would work. Starts with would work. Equivalence. Yeah, so like if you, for instance, if there were some errors in how people had listed their answers, like yes, maybe, then starts with is probably more useful. Like yes, if I have time, or no, thank you. You want to like log the no thank yous as no's, right? So having being able to use like string str.startswith would probably be preferable. But yeah, so it wouldn't be the same, but that would be useful in some cases. So a little bit about missing values. One of the helpful things is being able to look for things that are not in your data frame, right? So here are two tools that I use a lot with Pandas. The first one is looking for things that are missing. So you can use this kind of dot notation. So data frame, whatever it's called, your data frame dot is null. So that's a specific method, is null. So checks for null values. Dot values, so it's looking at the values. And dot any looks for any. Because all of this data is in memory, it doesn't have to, loop through. It's just going to look for if there are any missing values in the data frame. The dot drop na is a way to drop missing values. So if you do have values that are, where there's like a lot of missing, a lot of missing information, you can kind of quickly drop all of those. Keeping in mind that, since this is a highly mutable object, deleting things is an aggressive technique, right? You can also just drop like a specific column, let's say. So this other technique, drop na, is a way to drop rows. If you want to drop columns, it's dot drop, and then you pass the column name in as a string. And access one in place true says don't mess up what the access is. So it doesn't mess up the ordering. Once you drop a column, you want to make sure that it joins it, without kind of changing the row structure, right? So you just want to kind of clip out that column. So dot drop and then passing the column name and then specifying that you want to do it in place is the way to drop columns. So a little bit on imputation. In addition to dropping nas, which is what we saw here, df.dropNa, you can fill na also, and you can pass the fill na method with the number that you want to fill them with. So sometimes you want it to be a number. You can also pass a string here. So you could pass none, or you could pass some other text like missing information, missing. You can also specifically do that for a single column if you wanted to. So you could just fill the missing values for one or two of your columns if you wanted. But what I would like to kind of suggest here is that a missing value is not the same thing as a zero. And so there are smarter ways to do imputation, right? Like what, for instance? What would be a better way to impute missing values than just giving them all zeros? So yeah, so something that's not a valid value otherwise, right? Like because you don't want to change the tendency of the data So biasing it towards 0 could like significantly change the central tendency, right? So you could pass in like some text that won't change the tendency. You could also pass in the mean. So we already know that there's a dot mean method, right? So you could actually pass in dot mean into there instead of 0, and then if you're using the average value for that column to fill in the missing ones, then you don't change the central tendency at all, right? So that is kind of probably a smarter way to do this. It sort of depends on how many missing values you have and what counts as a valid value. So we have about 30 minutes left. Is that right? So what I would like you to do is, I'm going to open this up to, one of the kind of goals of this class is to talk about using wrangling because of some other thing, right? So that wrangling isn't, something that you do in a vacuum. It has a purpose. So this is an exercise that I built for a class that I teach at Georgetown. And the idea is, it's based on a Kaggle competition. So I'm not sure if people are familiar with Kaggle. Do people know about Kaggle? No. Kaggle is like a data science competition platform, basically. So companies, and organizations will put out data science challenges. Like they'll make a data set available, and they'll, hold a competition, and whoever comes up with the best, predictive model, for instance, wins the competition, right? And so you get posted on the website, you're on the leaderboard, and it's a way to get attention. So this is a challenge that they had that I think has passed already. But the idea is that you get this data set that tells you who lived and who perished in the Titanic. And they want you to use the data that you have about these passengers to predict survival and death, which is very kind of interesting. It's a very interesting data set. And so if you would like to kind of play with this, it's broken into sort of 2 steps. The first is an exploratory analysis and wrangling step. And the second is the actual machine learning component. But everything is here for you. So there's a folder here that has the data sets. So the data set that you want to explore is the train data set. But you'll see that here in the dataset folder, there are 2 files. There's test and train. That's because in machine learning, we break our data sets apart, right? So that we can have validation separate from how we actually build the model. So, but what you need to keep in mind is that however you transform the train data set needs to be replicable in order to make those same transformations on the test data set, right? So this is why we need to kind of think about wrangling as part of a pipeline. So you can kind of check out that data set and explore it a little bit. If you have access to command line Git and GitHub tools, then you can clone this the way that you did with Hathor. I think I have the instructions up here. Yeah, so you git clone, and then you paste in so you have to click on clone or download now, which is really irritating. But you can use that to access the link for Git. So you copy that, and then in your command line, you say git clone, and then paste that in, cd into Titanic, and then you can open up a IPython notebook by typing IPython notebook or Jupyter notebook, depending on which one you use. They will both work for this. So there's 2 IPython notebooks. The second one is this one that's listed as ML, so that stands for machine learning. So what we want is the wrangling one. So if you don't have access to command line tools, you can actually just sort of explore what this looks like. One thing that's sort of different here is that we are starting to make use of database tools. So SQLite is a way to instantiate a lightweight database using Python. It's one of the dependencies that was listed, for this class. If you didn't get it, but you have Anacondas, you already have SQLite, I believe. And if you are using a different distribution of Python, you can pip install SQLite 3. So here you can kind of walk through this process of, exploring. This is the answers are not filled in here, so you'd have to kind of figure out how to do this. So we set up our data frame. So you need to kind of put in here PD dot what do you remember the method for opening up a CSV? So it'll be PD dot read underscore CSV, and then you pass in the path, right? So you can kind of play with this a little bit. It guides you through asking a couple of questions of your data set and starting to think about what some of the problems are in the data set, but also starting to think about which of the columns, which of the features is what we would say in machine learning, which of the features are predictive and which ones are not predictive. And you can use like the summary statistics and other kinds of kind of mathematical operations and some visualizations to start thinking about, so here are some of the visualizations using Matplotlib. You can start to use these to explore the features that you think are likely to be predictive or less predictive of survival aboard the Titanic. So let's see, 35 after. So maybe we'll do like 5 minutes to kind of explore this, or 10 minutes? 10 minutes? 10 minutes to kind of explore this. If you want to find the answers, there's actually a solution branch for this repo. You can access the solution branch from your command line by running git checkout solution. Otherwise, if you're working in your browser, you can just click on branch and switch to the solution branch and look for the solutions. So you can see what the Pandas code is to do all of the operations, but I would encourage you to try it on your own first. And the other thing that I've done here is I've tried to punctuate all the questions with links to the documentation. So I think that, the trick of doing a lot of this is just getting good at reading the documentation and figuring out how to adjust the default parameters so that the methods actually do what you want them to do. For instance, here in the place where you have to use the read CSV method, there's actually a link to the Pandas documentation for read CSV. Likewise with, a lot of the other, so I've provided some hints here in case you need a reminder. But I think for most of these things, these are things that we've gone through, methods we've gone through in the slides already. So they should be familiar to you. So let's give us 10 minutes and then we'll come back and we'll sum up in the last 10 or 15 minutes and talk about what Pandas can and cannot do and kind of talk about next steps in your process of taking your wrangling to the next level. Okay, so I'm just going to kind of quickly point out a couple of things. So I pointed you to the solutions branch here. So once you're ready to check that out, you can. But you know, here is this dot head function that we can use to sort of explore. I passed it 10, so we're exploring the first 10 rows here. And I think, you know, what you can see from this is a really good argument for why you need to do wrangling in order to do predictive modeling. You know, we've got text here, we've got a name column that's going to be a problem when it comes to modeling. We've got specs encoded as string values. We've got a lot of missing values, you know, particularly here in the cabin column. You know, some of the ages are missing. So you can start to see, you know, that in order to build a predictive model to be able to guess the kinds of people who live and die, you know, you need to be able to do kind of significant kinds of wrangling. So you can, you know, on your own time, if you'd like, go through some of the techniques that I would use to sort of unpack what's going on in this data set and start to get it ready. And then if you're curious to see kind of what happens next, you can check out the second notebook, which is the machine learning one. Start to see how you would use tools in Python and Pandas to actually make predictions, which is a big part of what I do for my job. I wanted to point out a couple of things. If you're already used to SQL, here are a couple of things that you probably might ask about or might wonder about. Or if you're not used to SQL and you need to do aggregation or grouping or concatenation, these are some, a couple of useful methods to know. This is the .group_by method is really helpful for doing a lot of aggregation tasks. So in this case, we're going to first group the years, and then it's going to list the movie releases by year. You can also do data frame concatenation with Pandas. In fact, there's a couple of different ways you can do concatenation. You can actually use the .concat method, and you can pass concat a list of data frames. In this case, it's important that the indices don't overlap. You can also do appending. So this, in fact, in these two cases, you end up with a very similar result. But in one case, we're using, we're defining the frames in advance and then passing them to .concat. And then in the next case, we're actually calling append on the first data frame with the second one and assigning it to a new data frame. You can also do joins with Pandas. So if appending and concatenation is sort of like, putting stuff on top of each other, then the joins are kind of putting things next to each other is, one way to think of it. It's a little bit simplified. But this is how you would do, a merge of this left data frame and this right data frame. And in this case, it's important that the key values line up, right? So it needs to know how to merge them. So you have to pass it, you have to specify how you're going to do the merge. And here you tell it that the primary key or the key that they have in common is called key, right? But Pandas makes this pretty easy. Another thing that people sometimes ask me about is how do you get like dummy categoricals, or how do you convert categoricals into indicators? So this is something that, like, for instance, a lot of people who use Theta, and R do this. So it's actually pretty easy using this get dummies method. So this is a way to kind of quickly sparsify your data set if you need, like if you have, for instance, a column that has 5 different values like red, blue, green, yellow, purple. You can change each of those values in a column to actually be its own column, where the value for that column for that row is a 1 if it's purple and a 0 if it's not purple, right? So that ends up being a really useful tool as well. We've talked a little bit about kind of what happens after wrangling, and I just want to point out that Pandas really connects well with scikit-learn, which is kind of the heavyweight machine learning package in Python. So if you already have your data structured as a data frame, it's 4 lines of code to make a prediction on that data set, which is incredibly powerful. You can also pass NumPy arrays into scikit-learn machine learning models, but data frames kind of have this nice structure where you can kind of point specifically to the part of the data frame that's the features, and then specifically to the part of the data frame that's the labels, and this is assuming that we're doing supervised machine learning, which a linear regression or a logistic regression is an example. So that makes it pretty easy. I also want to point out that it's actually very easy to just, once you've wrangled a data frame, you can just save it back to a new CSV file. So remember when I said worm storage at the beginning of this? So worm storage, write once, read many. So don't ever change your original data set. Keep that one somewhere. Don't mess with it. Create a new data set with a new path, and just pass the name of the new path to the .toCSV method. So here we've got a data frame. You say whatever the name of the data frame is, df .to_CSV. You pass it the name of the path of the new file name you want to use. You can tell it, not to assign it an index if you want. You can tell it to remember the headers, the names of the columns, and you can also tell it specifically, how you want to do the separation. We also saw a little bit of this in the Titanic example. Pandas connects really well with SQLite. So if you already know SQL, you can kind of take advantage of that. I also wanted to say a little bit about some of the limitations of Pandas. So I mentioned that Pandas is limited because it's, it creates these data frame objects that are very, very mutable, which means that they are memory intensive, right? So if you are looking to sort of scale up from Pandas, I would encourage you to look into NumPy. In fact, every data frame in Pandas is really just a bunch of NumPy arrays under the hood. So if you already know NumPy, you can actually end up using most of the NumPy methods that you already know in Pandas, because Pandas data frames are just kind of bunches of NumPy arrays. If you are using if you have a lot of data, I would strongly suggest checking out the Python CSV module, which is a much better tool for large data sets, because you access data in a much more memory efficient way. And I would suggest using something like, something that kind of is a good balance between mutability and immutability, like something like named tuples is a nice tool to use for very large data sets. We've already talked about Postgres a little bit. Postgres is a fantastic tool. If you have very large data sets, you can actually kind of end up doing a lot of what we just looked at in Pandas in Postgres, but Postgres will handle much larger data sets. I also wanted to point out that we've had 2 classes already in the series that start to get at some of these kind of data wrangling things. You know, we didn't explicitly call them data wrangling in those classes, but I would encourage people to check out the Data Academy GitHub page. And if you haven't taken Intro to R and Intro to Data Analysis with R, those are also, you know, I think great tools. You know, like I've already said, Pandas is basically just like a hacky Python way to get an R data frame. So if you just want to go straight to R, I will not be offended. I think R is a very good tool in concert with Python for a lot of data wrangling tasks. So I encourage you to check out those courses. I also wanted to point you towards a couple of resources. So Brandon Rhodes is a friend. He is a Python programmer. He taught a really cool tutorial at PyCon in 2015 that kind of shows you soup to nuts how to use Pandas. So you can watch the video for free. It's about 2.5 hours. And then there's a couple of other great video tutorials if you are interested in learning a little bit more about Pandas. And then here's a list of non-video resources if you just want to, you know, read up on, you know, some of people's ideas about useful things that you can do in Pandas. Again, we'll be sending out these materials. I think in the email you got last week, you got a draft version of these slides, so we'll send out the updated version and I think the recording of this, and it will be on the GitHub page also, so you'll be able to access all of these materials that way. You know, just to kind of suggest like where else you can go for more stuff about data science generally, these are the pages that I use. KD Nuggets, Data Community DC's webpage, District Data Labs, blog, Stack Overflow and Stack Exchange, and then Coursera, of course, has great free materials. Also, there are a bunch of books that cover data wrangling type topics. In fact, most of them are going to block your exit on the way out. So if you're in the room, you can check those out on the table there. And you can also check these out online if you are calling in through the WebEx. You know, I'd suggest checking out these O'Reilly books. There's actually a new one that's not listed here that's called Data Wrangling Python that just came out recently that I would strongly suggest checking out. I also want to give a quick nod of thanks to the people who taught me Python and data science, Benjamin Bengfort and Alan Leitz. They're both faculty at Georgetown School of Continuing Studies with me, and they are graduate students working on PhDs at the University of Maryland, College Park, and I cribbed a lot of their slides for this presentation when I found out that I was going to be teaching this class. So they know a lot, and they have a lot of really great resources in their GitHub profiles. So I would strongly suggest checking out what they have in GitHub, and also, you know, following them on Twitter to see what they are working on. And if you have additional questions about this class or upcoming classes or past classes, you can email dataacademy@doc.gov. And I think we're out of time, so thanks very much. You're welcome to send, you know, if you have questions that come up later, you can shoot us an email. Check out the materials we have on GitHub, and good luck wrangling.